We're at the solution stage of EarthX with the founder of Map the Gaps, Tim Kearns. Welcome to EarthX. Tim, you need to tell me what maps we need to bridge that gap, which gaps we should be aware of. But before we go there, you want to explore the oceans and tell us more what's happening there. And you want to do that at a time when we're all excited about going to the moon again. And of course, your organization has been around for a while, but at this time, it seems that people are more interested in exploring outer space than the depth of the oceans on Earth. So, why are you doing what you're doing?
Well, thanks, Urin, and it's great to be here at EarthX 2026. The opportunity for 4 people to go to the moon the last few weeks was amazing. And I like to sort of remark that only 4 people got to see the dark side of the moon, but anybody should be able to see the bottom of the ocean. And we're trying to create an opportunity to do that. The space race of the 60s was long past for many of us. But the opportunity to be involved in something as transformational as that was decades ago is right in front of us, which is exploring our own planet. And so the recent mission to the moon has been a great opportunity to rekindle interest in ocean exploration, and in my business in particular, ocean floor exploration, which is what we're doing at Map the Gaps.
So, today, with devices or technologies like Google Earth, we can basically see anything on the planet, right? The maps of the planet, the surface of the planet are very well accessible. We know where we are. But that's not so for the ocean floor, isn't it?
That's great.
How much of the ocean floor has been mapped at all?
Approximately 28% has been mapped. And by mapped, that means measurements measuring from the surface to the depth. It may not mean a lot of measurements. It means one measurement every 500 meters or so. So we're not talking high resolution. We're talking low resolution data. Nonetheless, we've only got about 28% of 70% of the planet that has been mapped in even low resolution. So we're trying to advocate for high resolution, comprehensive coverage of the ocean floor.
Is it even possible that you're going to find depth that we didn't even know was there? I mean, we always say the deepest point is wherever it is, and it is 9 kilometers or something, right?
Right.
But could you find, whatever, a 15 kilometer deep crevice somewhere that nobody knows is there?
It's possible. It is possible because we haven't fully explored the oceans. Now, we've got lots of great gravitational models, so I think we have a general idea of how deep the oceans are. And Victor Vescovo, of course, a few years ago on the 5 Deeps mission, went around to every single ocean to identify precisely where the deepest parts of the ocean were. And he did that with modern technology, which was great. But that was just a tiny, tiny sliver of what's actually down there. And so, yeah, we really need to do a better job of understanding the oceans.
We need to do it. We haven't done it, and why not? And it makes sense to look at your own space first before you go to some other place in the universe. I get all that. But you have more important reasons than just mapping the oceans. I mean, tell me why this is important for all of us.
It boils down into 2 broad categories. One is an economic or a very practical reason to do it, and another is a real human reason to do it. So on the economic side, it's weather and climate prediction and modeling. And the oceans regulate our temperature on Earth. And so we need to understand how water moves, which is governed by valleys and mountains and canyons. Another is disaster preparedness, of course, tsunami modeling, sea level rise. We need to understand the shape of the seafloor in order to predict what's going to happen when these water masses come onto land. From an economic, a purely economic standpoint, 95% of the internet connectivity on Earth is on the ocean floor. And yet we don't have a very good understanding. And even in the case of international actors where there could be nefarious activities on the seafloor. We need to understand what's down there so we can protect these assets and resources. There's the whole blue economy, which involves marine resources, benthic habitat, the commercial fishery, potential, mineral extraction, which I'm not advocating for, but once again, we need to understand the characterization and the shape of the seafloor so we can better protect it, really. From a biodiversity and medicinal standpoint, one of my colleagues, Maranka Harris, is doing phenomenal research on extracting pharmaceuticals from deep sea organisms that are potentially leading to cancer cures and other medical advancements. And the biodiversity, I was just speaking to a woman this morning who was talking about all these amazing creatures that live in the canyon off of New York. And but it's poorly understood and it's still open to a fishery. And so we need to protect, we can't protect what we don't understand, and we can't understand what we don't measure, all reasons. On the human side, it's equally as important, albeit for different reasons. But certainly one is, the ocean is a time capsule of what came before us. So shipwrecks and preserving and documenting these stories from people who came before us, and that's not, yeah, many of those happened 100 or 1,000 or decades and decades ago. But then there's also closure for families. You look at the families of the MH370, for instance, where they're still waiting to find out what happened. And so there's other reasons to do it. Again, on the human side, there's kind of that insatiable curiosity that humans have, right? Which is to discover that completionist itch to figure out what's there. You don't buy a house and never go in the basement. Why do we live in a house that I've never been
This
there?
is a good point, because that also must have, inspired you to start this organization. So why did that happen? How did you come to this idea?
Well, I'm just a regular guy. I'm not a wealthy person. I don't have a PhD in oceanography. And although I started my career on ships doing ocean floor mapping, and it was very exciting, I also learned to appreciate how big the oceans are and how long it's going to take. And so as my career evolved and I realized that my opportunity to do this personally was less and less, I came up with this idea to try and empower a whole world, a whole public community sector of ocean explorers to get everybody involved, because it shouldn't be limited to the few, but we'll also never do it if it's only limited to the few. These large institutes that are doing great work. I mean, absolutely, Ocean Exploration Trust, Mid-Ocean Institute, Rev Ocean, NOAA, of course, and other governments around the world are doing phenomenal work. It's difficult to scale. And so we need to broaden the community of who's involved in this activity, and that's what Map the Gaps is doing now.
So one of the things you mention, when you talk about the gaps in publications I've seen, you talk about democratizing ocean exploration. Help me understand the word democratizing.
Democratizing ocean discovery or ocean floor exploration, to me, means opening it up to anybody, really. You could be a sixth grade class in Oklahoma that wants to understand or wants to be a part of something bigger than yourself. This is a science mission. Yes, it is. But it's also a human mission. And there's no reason why any human shouldn't be able to participate in this. And so to me, the democratizing discovery really means it doesn't matter if it's my 86-year-old mother, or if it's a sixth grade class, or if it's a family in the middle of Asia. Everyone should be able to participate in this. And it doesn't really take that much, other than what we're doing now is allowing people to adopt a little piece of the ocean floor, and then they can track the progress. We use those funds to go and explore the ocean floor, give people a poster of what it looks like in their little piece of the ocean, and give them partial credit for any massive discoveries that are made there.
So it's wonderful that you have this mission to map whatever is there that we don't know in the oceans. But when you got the idea to start this organization, to launch it, didn't you have a sort of another dream that you were going to find something? Is there something you're looking for that you think, well, that would be great if we find that?
No, I really, truthfully, no. I'm not looking
You're
for
not a
anything in
dreamer.
particular. This isn't a secret mission to find Atlantis or spaceships on the bottom of the ocean. Map the Gaps was founded from the members of the team from the Shell Ocean Discovery X Prize, which I was a part of that team, and we won that competition, and it was very exciting. And we were a bit of a bad news bears. We had limited funding from the generously provided from the Nippon Foundation, but we were a group of people from all over the world that worked remotely through 2016 to 2019 to accomplish something amazing. And we wanted to keep that spirit alive, which is why we created Map the Gaps. And until just this year, it was a volunteer-run organization. We're putting people on ships and supporting missions, processing data. But we realized in the last couple of years that really the oceans are still really big and they're really deep, and we're never going to get it done with just a small community of people in this ocean mapping world. So let's open it up to everybody, which is what we're doing.
So how long will it take if you plan it out the way you see it now?
Well, the very first step for Map the Gaps right now is to raise a little bit of funding, to get support, to continue to develop this digital experience called Hexplorer, which will allow people to choose and adopt these hexagons on the ocean floor. That hopefully will happen this year in 2026. Then the next stage would be to have a large campaign to roll this out broadly across the world. Passengers on cruise ships, maritime companies, individuals, sixth grade classes in Oklahoma, whoever it may be, to adopt these hexagons and raise some funding. Then those funds then would be used to stimulate and innovate a new technology to go and do the mapping. It would still take at least, even if we started today, Victor Vescovo, colleague, has done some modeling of how long it would take. It would take at least a decade if we started today with a fleet of ships, both autonomous and semi-autonomous and traditional vessels.
So we ultimately, back to the moon, we got there once before, but because an American president said we need to be there within the decade, right? What kind of, who are the big players when it comes to ocean exploration who could really support your efforts?
Well, because most of the oceans are deeper than 3,000 meters and most of the oceans lie in international waters, we don't find a big government body that is responsible for it or willing to take the risk and the cost to do it. So it then falls to the International Hydrographic Organization, which has a mandate for nautical charting, of course, groups like Seabed 2030 and JEBCO, which they aggregate all the publicly available and nationally provided data and other scientifically provided data into a public database that is available, which is supportive. And all the data that Map the Gaps collects goes towards Seabed 2030, this international movement. Then there's, of course, the science organizations. Bob Ballard is here, of course, with Ocean Exploration Trust, which is doing phenomenal work, not just in seafloor mapping, but also discovery of gases and wildlife and marine biodiversity, and Column Schmidt Ocean Institute. And there's lots of new science organizations or even cruise vessels, expedition cruises, that are putting scientific equipment on their vessels. Part of it because there isn't an international government or a single body that's championing this. So who does that come down to? It comes down to us. And we need to take responsibility for our own planet. We need to do the discovery and the exploration. And that's what democratizing discovery is all about.
So you mentioned that only 4 people just saw the dark side of the moon. And if we add a few more Apollo missions from whatever, 60 years ago, there will be a few more. So how many people on Earth have been, say, deeper than 3,000 meters in the oceans? I mean, what are we talking about? Is that...
That's a good question. I don't know the answer. I think it's probably less than a dozen. Certainly, we had Don Ball and his colleague in the early 60s, I forget his name. And then fast forward many years, James Cameron developed some technology. People like Sylvia Earle have had amazing opportunities in their career. A good friend of mine, Dawn Wright, was the first woman to ascend down to Challenger Deep, and that was with Victor Vescovo. And he brought several people down on with his missions to the deepest points on Earth.
But you would say
not many.
It's less than 100, or
Yeah, for sure, it's less than 100.
Oh, that's amazing. So your approach is to have people adopt these hexagons, right?
Yes.
Tell us more how that actually works.
Well, as much as it would be as much as it would be great to provide, have the means to let everybody go down to the bottom of the ocean, it's also not practical, right? So the only way we can meaningfully do that then is to bring the bottom of the ocean to them. And so this concept of allowing people to adopt varying sizes of hexagons, whether it's a tiny one at 5 square kilometers, or maybe a corporation wants to sponsor one at 12,000 square kilometers, that map the gaps then once those areas are explored and mapped, and maybe they already have
And
been.
you can put your name on it.
We're developing a global registry of ocean hex tiles. Once it's adopted, and once it's done, it's done.
It's forever
Yeah,
Tim
it's
Kearns
forever.
hexagon.
And then we'll mail you a high quality print of what it looks like at the bottom of the ocean inside your hex.
Oh, that's good.
And so you can hang that on your wall and you can say, I was responsible for that.
But what? Give me an idea. What would you need to pay for that?
Oh, the prices would be as little as $100.
Uh-huh.
Yeah, $100 for 5 square kilometers and up to $100,000.
Every year or just once?
Just once. Just once. And then we would use those funds to go and do exploration missions.
Okay, so let's do the math here. If you do $100 for whatever that square is or hexagon you just said, but you know how big the ocean floor is. If you do that multiplied, how many millions are you raising that way?
Yeah, well, it could be a lot of money, but it's also a lot of money to do the exploration itself.
Of course, no, that's fine.
So-
but I'm just thinking you could raise probably billions like that.
I don't know. I haven't modeled out exactly.
You haven't done the whole model.
I
but
haven't
that's
done the
fine,
whole
that's fine.
model. Certainly, it would be millions of dollars, which would allow these high priority areas, marine protected areas, areas with critical habitat, areas inside EEZs of countries, to be mapped and explored and help with local and the blue economy development.
All right. So now you need to do all this. You have big plans. How do you map the ocean floor practically? What kind of technology do you use?
The most common one, and it hasn't changed a lot in many decades, is sonar technology.
Mhm.
Now, the advancements in sonar technology have been significant. Even when I started my career a few decades ago, it was largely single beam technology. This is a single measurement. You can think of it as a flashlight on a wall. And so the closer you get to the wall, the more detail you can see, and the further away you can see more, but you see less detail. And so multi-beam technology, which is usually from surface vessels, is the most practical way to do it. Now, there's advancements in technology that have allowed us to use semi-autonomous vehicles. It's still relatively slow going. You can think of it as mowing the lawn, and that's how it's
In the
done.
old-fashioned way.
In the ocean, it's back and forth, and you're literally covering the ocean floor. Now, usually what happens is if you discover something that's an anomaly or something that looks a little bit strange, because in such deep water we can't see high resolution, then we would need to go back and send a different vehicle out underneath a submersible vehicle. Could be human powered, but it's usually not, to go get those really high resolution images of the bottom. And that's where we make the real discoveries, shipwrecks and incredible discoveries around gases and biodiversity. But it all starts with surface vessel technology. It can't yet be done from space, except in the shallow waters, where we have good visibility down to about 50 meters. You can use something called satellite derived bathymetry, which is taking optical imagery from space and putting it through pretty complicated models, to be able to understand how deep the water is. And that's a super popular and increasingly becoming with higher accuracy, to be used in the coastal areas in particular, which is great from an economic standpoint, and the cost savings are significant.
Go back. But I think that thing they don't like. So can you back up 20 seconds? Let's see
Yeah.
again what you
With something called satellite derived bathymetry, you can measure the depths from space, but that's only down to about 50 meters, and it's only in clear waters, typically clear waters. You still require advanced image processing and human talent to be able to do it, but it's a great economic saver for nations that have limited resources to understand the bathymetry or the depths in their coastal areas.
We've talked about technology and about maps. All of that is practical, not necessarily very exciting, but it is something we need to do. But there is something in your smile that tells me there is something exciting about all this. What is the dream?
Well, it is exciting because it's exploring our own planet. And I couldn't think of anything more exciting than that. Now, maybe that's a personal thing, but humans are hardwired for exploration. I'm reading a book right now on the chemistry reasons, sort of, and the psychological reasons as to why that is. And it's fascinating. We're one of the only species, maybe the only species on the planet, that has an innate desire to go beyond our own habitat to understand and explore more. So, from a personal standpoint, I find it extremely fascinating. There's also a thrill when you're uncovering data of the ocean floor for the first time, and you know that you're the first human who has ever seen that. That's exciting to me. And it shouldn't be limited to just a handful of people. I feel that if someone's sponsoring a little portion of the ocean floor, they should get to be a part of that excitement as well.
Thank you, Tim.
Thanks, Julian.
Well done.